Suppose a plus b plus c equals to pi. We need to verify the following conditional trig identity. Now, this identity is referred to as a conditional trig identity because if we consider, let's say, the trigonometric identity sine squared theta plus cosine squared theta equals to 1, this is going to be an identity. That means it's going to be a true identity for any values of theta that we choose. However, for the above trigonometric identity to be true, it's going to follow from the fact that we can choose only specific values of a, b and c such that their sum is pi radians. Okay, so here what we'll do, we will not try to find out the value of a, b and c, but we will try to prove that the given identity is a true statement. So here we'll start from the left hand side. On the left hand side we have sine of the half angle a over 2 added to sine of the half angle b over 2 added to sine of the half angle c over 2. Now we're going to add the first term and the second term by taking help of the trigonometric formula. That means if we have sine of angle c added to sine of angle d, this is simply given by 2 times sine of the angle c plus d over 2 multiplied to cosine of the angle c minus d over 2. Fine. Now let's use this to combine the first two sine functions. So we should get 2 times sine of angle a plus b over 2, but we again have to divide by 2, so that makes it 4 in the denominator multiplied to cosine of the angle a minus b over 4 plus we have sine c over 2. But what we can do, we can change this angle c over 2. We're going to use the condition. That means since we have a plus b plus c, that's equals to pi, so c can be also expressed as pi minus the angle a plus b. Now we're going to take half of that angle, so we have c over 2 equals to pi over 2 minus a plus b divided by 2. Now what we'll do, since we need sine c over 2, we're going to take the sine function on both sides such that we get sine of c over 2 equals to sine of the angle pi over 2 minus we have a plus b over 2. Now what is sine of pi over 2 minus some angle theta? This is simply going to be equals to cosine of that angle theta such that we get cosine of a plus b over 2. In other words, what we are saying here, that sine of c over 2, this is the same as cosine of a plus b over 2 provided the sum of the three angles equals pi radians. Now what we have is sine c over 2. We can replace it with cosine of a plus b over 2. Fine. Now you can ask, why did we use this particular transformation? Why did we change sine c over 2 to cosine of a plus b over 2? Because as you can observe here, we need a term, a 1 on the right hand side. As we can see here, there is no such term here. But what we can do here, we can use the fact that whenever we have cosine of some angle theta, then this is simply equals to 1 minus 2 times sine squared theta over 2. That's the half angle formula. Now converting cosine theta to 1 minus 2 sine squared theta over 2, that gives us that term 1 which we need. So our second term is going to become, so let's keep the first term as it is. We have 2 times sine of the angle a plus b over 4 multiplied to cosine of the angle a minus b over 4. Now cosine of a plus b over 2, so when we use this formula, we're going to get plus 1 minus 2 times sine squared. Now we have to take half of that angle theta. Our theta is a plus b over 2. When we take the half of that angle, we're going to get a plus b over 4. Okay, so now we have the term 1. We'll keep it aside. We'll not use it. We'll keep the first term as it is. Then also we see that we have 1 added to 4 times the product of these sine functions. So what we'll do, we're going to take the first term and the third term, and from both of the two terms here we can easily take 2 times sine of the angle a plus b over 4 as the common factor. Now we have done this because we need sine of a plus b over 4. So here we have obtained sine of a plus b over 4. We have also got 1 factor 2 out of 4. The rest we can find out easily. So that will be the goal. So 2 times sine of a plus b over 4, when we take it as a common factor, this is going to get multiplied to cosine of a minus b over 4. Then from this term we have negative sine of a plus b over 4. Fine. Now we have here is the difference of a cosine function and a sine function. Now, in order to be able to take the difference of those two trigonometric functions, both of them have to be the same. That means if the first one is the cosine function, the second one must be also a cosine function. So what we'll do, we'll try to convert this sine a plus b over 4 to a cosine function. Now, how shall we do that? Here we are going to use a fact. We know that if we have sine of some angle theta, this is also the same as cosine of pi over 2 minus theta. Now, in our case, if we consider theta to be equivalent to a plus b over 4, then we should get sine of a plus b over 4. This is going to be the same as cosine of the angle pi over 2 minus, now in place of theta, we have a plus b over 4. Okay, so let's combine it. This is going to give us cosine of the angle 2 pi minus a minus b divided by 4. So in other words, what we are saying, that sine of a plus b over 4, this is the same as cosine of 2 pi minus a minus b over 4. So let's use that. So we will get cosine of 2 pi minus a minus b divided by 4. Now we are ready to combine these two cosine functions because this is the difference of two cosine functions. So here we're going to take help of the formula. That means whenever we have cosine of angle C minus cosine of angle D, this is going to be equals to 2 times sine of the angle D plus C over 2 multiplied to sine of the angle D minus C over 2. So here we will get 1 plus 2 multiplied to sine of the angle A plus B over 4. Now, taking the difference of the two cosine function, this is going to give us 2 times sine of the angle. So we need D plus C over 2. So what is D here? So if we consider A minus B over 4, this is equivalent to C, and 2 pi minus A minus B over 4 as equivalent to D. So here, adding them and dividing by 2, that's going to give us pi minus b divided by 4. And next, this is going to get multiplied to sine of d minus c over 2. Now, when we do d minus c, that's going to give us pi minus a divided by 4. Okay, this will be 1 added to. So 2 and 2 gets multiplied to give us 4. We get 4 times sine of the angle a plus b over 4 multiplied to sine of, we have pi minus b over 4. But here we're going to use the fact that since a plus b plus c, that's equals to pi. Now, pi minus b is what? Pi minus b is simply equals to c plus a. And so we can replace it with c plus a over 4 multiplied to sine of the angle pi minus a over 4. So again, using this relation, we can have pi minus a equivalent to b plus c. So here we can replace it with b plus c divided by 4. And this is exactly the expression on the right hand side. This is the expression on the right hand side. So we can say thus there we have the left hand side equals to the right hand side. Hence proved. So let's check the problem once more. So sine of a over 2 plus sine of b over 2 plus sine of c over 2 equals to 1 added to 4 times the product sine of a plus b over 4 times sine of b plus c over 4 times sine of c plus a over 4. And this is going to be true based on the condition that a plus b plus c equals to pi radians.